Namaste, my friend, and welcome back to JEE Physics with Typical Monk. This is class 3, and today, motion finally grows a second dimension. Until now, velocity and acceleration were simple numbers on a line. From here on, they are vectors with both a size and a direction, and adding them is not as easy as adding numbers. When Sarah first solved a projectile problem, she added the horizontal and vertical speeds like ordinary numbers, and her answer came out simply wrong. Because velocity is not a number, it is an arrow. Today, we learn to add, resolve, and multiply these arrows properly, chase relative velocity through rain and rivers, and derive the projectile's parabola using nothing but calculus. And here is why this chapter rewards JEE aspirants specifically. NEET rarely touches vectors properly or asks about an incline, but JEE builds whole numericals on exactly this. Take a slow breath. Let us begin. So what will you carry home from today's class? First, vectors, how to add them, resolve them into components, build a unit vector, and use the dot and the cross product. Second, relative velocity in 2 dimensions, the classic rainman and riverboat problems. Third, projectile motion built from calculus, the trajectory equation, time of flight, maximum height, and range. Fourth, projectile motion on an inclined plane, where the range is measured along the slope itself. And fifth, the JEE drills, including closest approach problems that turn all of this into marks. Ready? One idea at a time. Let us build a toolkit first. Vectors add tip to tail, the triangle law. Draw the second vector starting from the tip of the first, and the resultant closes the triangle, running from the start of the first vector to the tip of the second. Any vector can be resolved into 2 perpendicular parts, a horizontal component and a vertical component, and together those 2 components rebuild the original vector exactly. A unit vector carries no size at all, only direction. You get it by dividing a vector by its own magnitude. And 2 ways to multiply vectors. The dot product gives back a plain number, largest when the vectors point the same way, and the cross product gives back another vector, largest when the vectors are perpendicular. Look at this diagram carefully. It holds 2 ideas at once. On top, the triangle law in action, vector A, then vector B, drawn from its tip, and the resultant closing the triangle. Its magnitude comes from the cosine rule. The square root of a squared plus b squared plus 2 times a times b times cosine of the angle between them. Below, the same vector are resolved along 2 perpendicular axes. The horizontal part is a times cosine theta, and the vertical part is a times sine theta. David used to draw every vector problem freehand and guess the angles. The day he learned to resolve onto perpendicular axes first, his answers stopped needing guesswork. Now a question that trips up half the class. Whose motion are we even describing? Relative velocity is simply a subtraction of vectors. The velocity of one object as seen from another is the first velocity minus the second. In the rainman problem, rain looks like it is falling straight down to a walking man only when his own velocity exactly cancels the horizontal part of the rain's velocity. In the riverboat problem, steering the boat straight across gives the shortest time but not the shortest path. The shortest path needs the boat angled upstream. And for the closest approach between 2 moving bodies, write their separation as a function of time and minimize it. Lisa once assumed the closest point was wherever the 2 paths crossed and lost the question. Because with different speeds, the true closest approach happens somewhere else entirely. Time to solve a full JEE numerical together, slowly, the monk's way. A ball is launched from the bottom of a rough incline with a speed of 20 meters per second, at an angle of 60 degrees to the horizontal, up a slope that rises at 30 degrees, with gravity taken as 10 meters per second squared. Find the range along the incline. Step 1. Write down what is given. Speed 20 meters per second, angle of projection 60 degrees from the horizontal, incline angle 30 degrees, gravity 10 meters per second squared. Step 2. The formula. Resolving gravity along and perpendicular to the slope gives the range along the incline as 2 times u squared times sine of theta minus beta times cosine theta divided by g times cosine squared beta. Step 3. The numerator. Theta minus beta is 30 degrees, so sine 30 degrees is 0.5 and cosine 60 degrees is also 0.5. U squared is 20 squared, which is 400. So the numerator is 2 times 400 times 0.5 times 0.5, which is 200. Step 4. The denominator. Cosine squared of 30 degrees is 0.75. So the denominator is 10 times 0.75, which is 7.5. Step 5. Divide. 200 divided by 7.5 is about 26.7 meters. That is your range along the incline. And notice the method. Given formula, numerator, denominator, answer. The same 4 moves solve every incline projectile G can ask. Now, the projectile itself builds the calculus way, not just quoted. The horizontal velocity, u cosine theta, never changes during the whole flight because no force acts along the ground. The vertical velocity, u sine theta, keeps shrinking under gravity, and integrating it once more gives the maximum height, u squared sine squared theta, divided by 2g. Integrate both motions together and eliminate time, and out comes the trajectory equation itself. Y equals x tan theta minus gx squared over 2u squared cosine squared theta, the exact shape of the parabola. From the same integration, the time of flight is 2u sine theta over g, and the range is u squared sine of 2 theta over g, which is largest when theta is 45 degrees. Now sit up straight. These 5 lines are what G actually asks, year after year. 1. Range is u squared sine of 2 theta over g, and it is maximum at 45 degrees, because sine of 2 theta can never exceed 1. 2. Horizontal velocity never changes in flight. Gravity only ever touches the vertical component. 3. The dot product tells you how parallel 2 vectors are. The cross product tells you how perpendicular they are. 4. Rain, river, and closest approach problems are all the same trick in disguise. Subtract the velocity vectors. 5. On an incline, resolve gravity into its part along the slope and its part perpendicular to it before touching any kinematics formula. Let us drill the G way. Remember the 4 options. Option A, both statements true, and the reason explains the assertion. Option B, both true, but the reason does not explain the assertion. Option C, assertion true, reason false. Option D, assertion false, reason true. First one, assertion for a projectile. The range is maximum when it is launched at 45 degrees. Reason, range equals u squared sine of 2 theta over g, which is largest when sine of 2 theta equals 1, at theta equal to 45 degrees. Both true, and the reason explains the assertion perfectly. Option A. Second one, assertion. The dot product of 2 perpendicular vectors is 0. Reason, the cross product of 2 parallel vectors is also 0. Both statements are true on their own. But pause, does the reason explain the assertion? No. They are 2 separate facts about 2 different pairs of vectors. Both true, but the reason does not explain the assertion. Option B. Third one, assertion. If the angle between 2 vectors is 90 degrees, their dot product is 1 and their cross product is 0. Reason, cosine of 90 degrees is 0 and sine of 90 degrees is 1. Check the reason first. That is simply true. Now the assertion. At 90 degrees the dot product is actually 0 not 1 and the cross product is at its maximum, not 0. The assertion has the 2 products swapped. Assertion false, reason true, option D. This is the trap that catches John every time, mixing up which product survives a right angle. A quick match now. Say each formula aloud before I reveal it. Time of flight, 2u sine theta over g. Maximum height, u squared sine squared theta over 2g. Range, u squared sine of 2 theta over g. And the magnitude of the cross product, a b sine theta. If all 4 came to you before the reveal, this chapter is becoming yours. Here's a favorite G format. I will read some statements. You silently count how many are correct. Statement 1. The horizontal component of a projectile's velocity stays unchanged throughout its flight. Hold your verdict. Statement 2. Two anti-parallel vectors give the maximum possible dot product. Think about what cosine of 180 degrees actually equals. Statement 3. The relative velocity of rain with respect to a running man is the vector difference of their two velocities. So, how many are correct? Two statements. The first and the third. Horizontal velocity truly never changes in flight, and relative velocity truly is a vector subtraction. But the second one, false. Anti-parallel vectors give the most negative dot product, the minimum, not the maximum. Two correct, and the middle one is the trap. Now let me save you some marks. Two myths that trap thousands of students every year. Myth 1. Adding two vectors always means adding their magnitudes. 5 and 3 should always make 8. But here is the truth. The resultant depends entirely on the angle between the two vectors. Magnitudes only add directly when both vectors point exactly the same way. Myth 2. If a boat is steered exactly perpendicular to the river's current, it takes the shortest path straight across. The truth, perpendicular steering gives the shortest time, not the shortest path. For the shortest path, the boat must angle itself upstream, fighting the current the whole way. One myth, one full G question. Do not let it be the one that costs you. Time to test yourself, rapid fire, and every answer today is a number. Here is the rule. I ask, you answer in your head before the reveal. No pen, no paper, just what you built today. Question 1. A ball is projected at 45 degrees with a speed of 10 meters per second. Gravity 10 meters per second squared. What is its range? U squared sine 90 over G 10 meters. Question 2. Same idea, different numbers. Speed 20 meters per second at 30 degrees, gravity 10 meters per second squared. What is the time of flight? 2u sine theta over G 2 seconds. Competing question. Free same projectile. What is its maximum height? U squared sine squared theta over 2G 5 meters. Question 4. A boat aims straight across a river, 100 meters wide, moving at 5 meters per second, while the current runs at 3 meters per second downstream. How long does it take to cross? Wide divided by the boat's own speed, 20 seconds. The current only decides the drift, not the crossing time. And question 5. The thinker. Two vectors of magnitude 3 units and 4 units have a dot product of 6. What is the angle between them? Cosine theta equals 6 divided by 3 times 4, which is 0.5. Theta is 60 degrees. If you caught that one, you have truly understood today's class. Let us gather the whole class in one slow breath. Vectors added to tail. The triangle law gives both the size and the direction of the resultant. The dot product is a plane number, a b cosine theta. The cross product is a vector, a b sine theta, perpendicular to both original vectors. Relative velocity is a vector subtraction. It solves every rainman and riverboat problem the same way. A projectile is two independent motions at once. Constant velocity horizontally, uniformly accelerated vertically, and calculus turns that into the trajectory, the height and the range. On an incline, gravity splits along and perpendicular to the slope, which changes both the flight time and the range along it. And next class, we meet the force behind all this motion. Laws of motion and friction, free body diagrams, connected bodies on a pulley, and friction on a rough incline. Do not miss it. And so, my friend, motion has grown a second dimension, and you have grown with it. Sarah, David, Lisa, and John all once added vectors, like plain numbers, and paid for it. You now know better. Be patient with yourself. Tonight, revise just one thing, slowly. Relative velocity is always a subtraction, never an addition. One idea at a time, you will crack G. Of this I am certain. If this class brought you clarity, subscribe to the channel so the next one finds you. Until then, keep going. I will see you where the force begins.